Let's talk about complex numbers. Recall that I is equal to the square root of -1. Typically, we say we can't square root a negative, but if we are in imaginary number world, we are allowed to. So if we take the square root of -1, we're going to get I. Thus, I squared is going to be the square root of -1 times the square root of -1. You're going to get -1. A complex number is an expression of the form a plus bi, where a is considered to be the real part of the number, and the bi part, this is your imaginary part. So you might have something like 3 plus 4i, or 10 minus 7i. These are considered complex numbers. So we want to work a little bit more with our imaginary numbers because we are working into getting some imaginary zeros with our polynomials. So the square root of -64. To start simplifying these, I prefer to think about this as, instead of the square root of -64, think about -64 as -1 times 64. Because then that allows me to think of this as -1, the square root of -1 by itself, times the square root of 64. And we know the square root of 64 is 8, and we know the square root of -1 is I. So we would think of this as 8I. The square root of -20 we could simplify by taking the square root of -1 times the square root of 20. So again, we know the square root of -1 is I. And then we've already learned how to simplify the square root of 20. So one option that we've been working with is taking 20 and doing the prime factorization of it. So something like 2 times 10 and then 2 times 5. So the square root of 20 we could think of as 2 times 2 times 5. So then the square root of 2 times 2 would be a 2, and we'd still have the root 5. And we can't forget about the I over here. You'll see people write this a variety of ways. If we're thinking in terms of a plus bi, a lot of times we see the I at the end. So you might have 2 root 5 times I. You just need to make sure it's obvious the I isn't underneath the radical. So that's one way to write it. Or sometimes people prefer to have the radical at the end, so the 5 here, and then you'd have the 2I out front. I'm okay with either of them. It's really kind of your preference. The square root of -48, I'm going to think of this as the square root of -1 times the square root of 48. The square root of -1 is I. The square root of 48, you can do the prime factorization of that. So 48 we could think of as 4 times 12, for instance. 4 is 2 times 2. 12 is 2 times 6, and 6 is 2 times 3. So we would have 2 times 2, or 2 squared, times another 2 times 2, or 2 squared, times a 3. So then the square root of 2 squared is 2. The square root of 2 squared is another 2, and then you can't square root the 3. So 2 times 2, you're going to get 4 root 3, and you still have the I. So I would either write that as 4I root 3 or 4 root 3I. Either one of those is going to work. I probably tend to put the I at the end just because of this format. So the reason we need to know that is you're going to be solving for zeros in a lot of different quadratics, and some of those zeros are going to be either irrational, or in this case, they're going to be complex. So if we look at 3x squared minus 4x plus 7, it says find the zeros of the following quadratics. So we are taking 3x squared minus 4x plus 7, setting that equal to 0. If you were to try to factor it, 3 times 7 is 21. We would need factors of 21 that add up to be -4. Well, our factors of 21 are 1 and 21, or 3 and 7. Or if they were both negative, you could also get a positive 21, but none of those are going to add up to be -4. So the only way that we can do this is we're going to use the quadratic formula. So x equals -b, so b is -4, so -b is 4 plus or minus the square root of b squared. -4 squared is 16, minus 4 times a, which is 3, times c, which is 7, all divided by 2 times a, which 2 times 3 is 6. So if you use your calculator, we would want to figure out what's our discriminant first. So 16 minus 4 times 3 times 7. Well, 4 times 3 is 12, and then that times let's see, on my calculator, 12 times 7 is going to be 84. So if I do 16 minus 84, I get negative 68. So our discriminant is negative 68. If you were in Algebra 1 and you got a negative discriminant, you would have just stopped and you would have said, okay, there's no zeros, right? No answer. But now that we are familiar with imaginary numbers, we are going to actually simplify that. So if we would take that, we would want to figure out the prime factorization of negative 68. So again, I would be thinking of the square root of negative 68. I would do negative 1 times positive 68. So if we do the prime factorization of 68, 68 divided by 2 is 34. 34 divided by 2 is 17. And 17 is prime, so that can't go any further, and neither can either of those. So we could think of the square root of 68 as 2 times 2 times 7. So the square root of 2 squared is 2. So this is going to be root 17. That's a 17, not a 7. So we would be able to rewrite this, the square root of negative 68, instead as we would have 4 plus or minus, and then we have 2 root 17, and we have an I, right? The square root of that negative 1 is I. So I would think of this as 2 root 17 I, and it's still all over 6. Now, the last thing that we would want to do is see if we can simplify that. And I can see that there is actually a factor of 2 in here, in this term, and in the bottom. So if I factor a 2 out of the numerator, then I would have 2 plus or minus, and then I'd factor this 2 out. So it'd just be root 17i over that 6, and 2 over 6 reduces to 1 over 3. So my final answers here would be 2 plus or minus the root 17i over 3. And sometimes you'll see in your book or online, they might split that and say, oh, well, this is 2/3 plus or minus root 17 thirds over times I, because that looks a little bit more like the a plus bi. I honestly am okay if you write it this way or this way. Let's try one more. Negative 6x squared plus 2x minus 1. If we're setting that equal to 0 to solve, this is not going to be factorable, so we're going to use the quadratic formula. X equals negative b plus or minus the square root. B squared is 4 minus 4 times a is negative 6 times c is negative 1, all over 2 times a, which is over negative 12. Negative 2 plus or minus the square root of 4 minus 4 times negative 6 is negative 24 times a negative 1 is positive 24. So we're really doing 4 minus 24, which is going to be negative 20, all over negative 12. Well, we actually already worked with the square root of negative 20. We figured out that this is going to be considered negative 1 times the square root of 20, which we said the square root of 20, you could have 2 squared times 5 in the prime factorization, which means it's going to be that 2 root 5. So you have I times 2 root 5, or 2 root 5i. So this is negative 2 plus or minus 2 root 5i, all over negative 12. In this case, this can simplify further. I can see again that we have a factor of 2 in each of these. So if you factor a 2 out, you could think of this as negative 1 plus or minus root 5i over that negative 12. And 2 over negative 12 reduces to 1 over negative 6. So you could say this is negative 1 plus or minus root 5i over negative 6. And you could keep it like that, or you could say negative 1 over negative 6, which would simplify to a positive 1 over 6, plus or minus root 5i over that negative 6. So you could write it any way. And honestly, you're going to see even people would say that this wouldn't have to be negative anymore because of the plus or the minus. You could simplify it up here by factoring out a negative 2. The positives and negatives are a little bit different on this one, but I would just consider leaving it probably like this first answer here.